Etherchannel. Etherchannel allows you to bundle multiple physical links into a single logical interface called port channel. It is also known as port channels, channeling, link aggregation, NIC teaming. These are the these are the benefits of Etherchannel. Allows a wider bandwidth between switches, provides load balancing. Um, this video, I'm gonna mainly talk about load balancing in this video. So it provides load balancing, i.e., or that is distributing traffic on multiple links based on hash algorithm, not not equally balancing traffic. It creates redundant links, provides an optimization to STP by enabling all member ports to be placed into forwarding state. And it is independent of the port mode, so it can be access, trunk, layer 3, layer 2, tunnel, etc. So these are the uh, two protocols. So PAgP, port aggregation protocol, it's Cisco proprietary, and these are the modes: desirable and auto. Link aggregation, control protocol, or LACP, industry standard, dot 3AD, and these are the modes: active and passive. And this is there is another option, which is static lag. It's supported, but it's not actually recommended. So let me actually show that pretty quick. So let's say, oh, okay, let me go to switch to, oops. So let's say, um, ether channel, no. So let's say this port here, the configuration is channel group. So let's say 2. So mode is on. So this is the static lag, which is just enable Ethernet channel only. So meaning that you're not going to use either LACP or PAgP. So that's what you're going to use. What you are going to choose, that static option. Going back here, this is how you configure it. Lag is configured as the following. So just like I showed you here, channel group, number, mode, and these are the modes. So active, this is LACP. Passive, this is also LACP. Auto and desirable, these are PAgP. And this is how you configure uh, load balancing. You configure load balancing in the global configuration mode. So meaning that it will be applied to all the uh, port channels that you have on that device. Those port channel will use the same load balancing method. So this is actually, let me just show it to you. So port channel load balance. These are the algorithms that you can choose. So in this case, the switch has a default of this um, algorithm. So source destination IP, and I was able to check that by doing show run all load just balance. Oops. Yes, there you go. And these are the verification commands. So show either channel summary, show either channel load balance, and this here, this this here, and just some of the um, actions that you can do while actually performing. I mean, these are the actions that I'm going to perform in this video. So just do a ping, clear the counters, and just verify the interfaces. Okay, so let me show you the topology that I have here. So it's a very simple topology. I have switch 1, switch 2, and server 1, server 2 here on the right side connected to switch 2, and PC through PC4 are connected to switch 1. So let me go to switch 1 and switch 2. Let me do show ether channel summary. So as you can see, I have a port channel 1, and these are the member links 00, gig 01, gig 02, and gig 03. And that is the same case on switch 2 as well. Show ether channel summary. So yeah, port channel is layer 2, and it's in use. So that's the meaning of SU here. So it's the same ports. So let me actually perform a ping from switch 2 uh, all the way to just switch 1, so point to point. Switch 2, no, switch 1, switch 2. Let me do that command to verify the traffic on the interfaces. So as you can see, there's no traffic. This is the port channel, and this is the SBI interface. And these are the physical interfaces: 00, gig 01, gig 02, gig 03. So no traffic. And that is the same case on switch 1. Yeah, no traffic on the port channel interface. No traffic here on VLAN 1, and no traffic here. Gig 00 through gig 03. So, like I said earlier, this is actually how you verify the load balancing load balancing algorithm that is being used on the switch. So in this case, uh, I'm using source destination IP, and that is the case on switch 2 as well. Okay, so let's try to ping switch 1 from switch 2. As you can see, I'm using repeat 20, and size, I'm using maximum size actually here, maximum 18,024. So now let's check the traffic. Let me do that same command. I mean, let me do ping again. Oh, actually, let me just maximize. This is the first command that I did, but when I did it again, So here I see gig 03 being used for that ping, and as you can see here, uh, I see the traffic here, input rate. Let me do this. Let me do that ping again. Okay, so it looks like it's only using this this port 0/3, because the other ports, I mean the input rate or output rate on the other ports are not incrementing. Yeah, and I think we should say, let's check switch one. So switch one, let's check the physical ports. I ping switch one, right? Yeah, ping switch one. And they verify the IP address of switch one. Yes. But I don't see traffic here incrementing. Hmm. That's weird. Let me do it again. So switch one here, okay. We should see traffic here, right? There you go. I see it. I see it on the port channel itself, but not on the physical interfaces for some reason. But I think in reality we should see it as well on at least one of the physical ports. Let us do this. Let me ping from server 1. I'm going to ping PC1, PC2, PC3, and PC4 and see if things will change. So I'm going to ping PC1 that has this IP address. Going to ping PC2. And you know what? From server 2, I'm going to ping PC3, repeat 20 size 18024. I'm going to ping PC4. Okay, now let's check the ports on switch 1 and switch 2. Okay, so we see here that looks like only gig 0/0 is being used. At least the physical port. So let me do it again. Yeah, we see what's the 18. Well, we see more traffic on the port channel itself, which is actually weird because I think we should see the same, almost the same traffic, right, from the physical and logical port. Let's check switch 1. So switch 1 is has this traffic or input rate on the port channel, and maybe this is a bug this uh, with these devices in GNS3. But like I said, we should also see the same, almost the same traffic on the port, on the physical port as well. Um, let me do it again, or let us ping again. Let's try to ping again from server 1, pinging PC2, PC1, and from server 2 going to ping PC3, and I'm going to ping PC4. Let's now check the ports again on the switches. There we go. Now we see that 2 ports are being used. Physical ports are being used. Okay, so it looks like load balancing is working as expected. So in this case, so this is to verify that not all the ports are being used every time there is traffic going or traversing the port channel, right? So not all member links or physical links are being used at the same time. So this is a really good verification. So let me check switch 2. So from switch 2, switch 2, switch 2. Hold on. We don't see it on switch 2, the traffic incrementing from the physical ports. That is a bit weird. So like I said, it could be a bug on this device actually, but it's actually looking good on switch 1, right? So here, let me do that command again. Oh, looks like it is. Oh, it is timing out. Looks like it is timing out because before we were able to see it here. So let me actually do the same pings again and ping here, switch PC4. Let's check switch 2 right away. There we go. Yeah, it's actually timing out. I think it's working. It's just timing out. So we need to. It's working as expected, but it's just timing out. So we need to right away check the physical ports. So in this case, gig 0/0, we see traffic on gig 0/0, and we see traffic on gig 0/2. So these physical ports are being used for that ping that we performed. Let's check again switch 1. I guess timed out already. Yeah, it's not here anymore. Okay, but I think we have verified that, like I said before, not all ports are being used for the traffic that is traversing the port channel between the switches. So, yep, that's it in this video. Thanks for watching.